Hello, everybody, and welcome. We're going to be presenting on S3 storage in ClickHouse today, and we're going to be showing you basic and advanced wizardry for using this powerful feature for storing large amounts of data. My name is Robert Hodges, and I'm Altinity's CEO. I'm joined today by Alexander Zaitsev, who is the CTO, and also prepared substantial portions of this talk. He'll be with me to provide color commentary and also to go deep on questions at the end. Before we get going, I'd like to just cover a couple of things which will help you enjoy this webinar more. First of all, let me assure you it's being recorded. I can see it happening right now on the console, so we will send you a link to the recording as well as to these slides after the webinar. You'll probably get them within about 24 hours. So that's thing number one. Thing number two, this webinar is backed by a bunch of examples that are out on GitHub. I'll provide the link at the end, but the code samples that you're seeing here, you can actually go get them from GitHub and see how we did some of these things. So no need to take frantic notes on that or copy and paste out of the slides. Third thing, we will have time for questions, and if you want to pose questions as the talk is proceeding, feel free to put them in the question and answer box. That's available on the little console that Zoom provides, or you can stick them in the chat. We're not very picky. Whatever's necessary. If it's something directly relevant to the talk, I'll pause and answer it. Otherwise, we'll take them at the end. So with that, let's go ahead and dive in and do some introductions. So my name, once again, is Robert Hodges. I've been working on databases for actually 40 years, and I've been working with Kubernetes and distributed systems, which comes up a lot in our world since 2018. My day job is I'm CEO of Altinity. I've also got with me Alexander Zaitsev. Alexander, if you're able to unmute, we can test your audio and let you introduce yourself as well.
Hello, everybody. Can you hear me
Great.
well?
Yes,
Okay.
perfectly. So Alexander is, as you can see on the slide, expert in analytics. He was the person who really was the motivating force behind founding Altinity as a service provider for ClickHouse. And among the services and software that we provide, there's Altinity.cloud, first cloud for in Amazon and GCP for ClickHouse. Also runs on any Kubernetes. And we also are the producers of the Altinity stable builds, which some of you on this call use. And we're the authors of the Altinity Kubernetes operator for ClickHouse, as well as other great software like ClickHouse Backup. So we'll talk a little bit more about us at the end. If you want to contact us, anything, we're happy to discuss anything that's in this webinar to discover how we can work together and make it better. With that, let's go ahead and dive in. Oh, before I leave the introductions, I want to give a special shout out to Denis Zhiravlev. Many of you know him as Denny Crane. He provided some of the key examples that we're using in this talk, and is a past master at use of S3 in production situations. So I'm going to start by going into just how does S3 generally fit into ClickHouse, and we're going to proceed pretty quickly on this, so you won't be bored. We'll start with the obligatory slide on ClickHouse for those of you who are not familiar with it. It's a real-time analytic database. It's kind of like MySQL, the flexibility, the portability, the open source license, but it deals with billions or trillions of rows of analytic data. So it started out with a shared nothing architecture, which means that a bunch of nodes connected on a network with their own storage. As you'll see in this presentation, that is beginning to that architecture is now beginning to evolve into a fully blown separated compute storage. We can do this in multiple ways, but that's a whole another talk. Like all analytic databases, data is stored in columns, parallel and vectorized execution, very, very good scaling, and it's incredibly popular. It's one of the most popular certainly analytic databases on GitHub, and has something like 31,000 stars. So that's ClickHouse. What we're going to do is just start with the basics, putting a table into ClickHouse, and just to review how tables work. We'll be focused on the merge tree table engine, which is your workhorse for big data. It is designed to handle billions to trillions of rows distributed potentially over many machines. So in a table definition, we'll also typically, if the table is of any size, have a partition by clause, which tells us how to split the table up into parts. That's very important because it gives ClickHouse some guidance about how to divide the table up into reasonable chunks that it can then distribute to different locations. We'll also have ordering. So in column databases, ordering is critical. It enables us to create contiguous stretches of data. This is useful for this is useful for both for query performance and also for compression, which, as you know, are closely linked. And if we want to insert data in, this is a typical way that we would insert data into it. We're going to select artificial data out of the numbers using the numbers function, and we can just pop it in. This is a common way to populate data. And in fact, a command or similar to this one is used in all the examples that we talk about. So when we're using the traditional shared nothing storage, here's where the data goes. So you have ClickHouse, it's running as a process. It's got the merge tree engine. The data is on a disk somewhere, can be multiple disks nowadays. And you're going to have a combination of metadata, which is things that tell you how to find the data, like your database structure, your table structure, so on and so forth. And then you're going to have the actual table data itself. You're going to have the Linux page cache, which is a very important cache that is used to speed up operations on block devices. So that's your basic structure. Now, oops, we have a, there we go. Okay. Looks like we had a quirk there in the slides. So this, as most people know, has very good performance. So we have some test queries here. We'll be running these again and again as we go through the talk. But if we set this up so that, for example, we run these queries where we force ClickHouse to read everything from storage, which is using this little setting that's shown down at the bottom, we get about half a second max for these queries. And in fact, the first one, because there's an index we can use, it's extremely fast. It's a few milliseconds. And then once this is run and the data is sitting in the OS page cache, it drops by about half. In other cases, of course, you get a bit even bigger speed up, but in fact, the data we're dealing with is just not that large. So this is the thing that has made ClickHouse popular, is to have this speed. And you can see, by the way, what we're testing on. We're using ClickHouse 23.7, using M6i instances and EBS GP3 storage with 1,000 megabytes per second throughput. So a pretty performant setup. So as this grows, and as many of you have found, the shared nothing architecture has some big limitations. So one is that the capacity is limited. So it is practical to store far more data than most people suppose using this model. But once you get in the range of, say, 30, 40, or even 50 terabytes, it becomes difficult to manage. So it's not that you can't continue to add more devices. You can, and people can go bigger than this. But things like backups get complicated. If you ever have to, if a server flakes out and you have to replace it, it's very, very slow. That's thing number one. Thing number two, block storage, which we're using here, is relatively expensive. It can be glued in as SSDs, or it can be EBS if you're working in Amazon, similar cloud storage in other places. But it's relatively expensive, especially when you consider that in the replication model that's used in the shared nothing architecture, you make multiple copies. So it's more expensive storage, and then you multiply it. So for that reason, it's been pretty attractive for a long time to think about adding S3 to this. So S3 object storage is a generic form of storage. You can put data into it basically in files. You can get them back out again, and it has a number of very desirable properties. One is it has virtually unlimited capacity. I mean, it does have a limit, but nobody on this call is likely to hit it. As a storage, just for pure storage costs, it runs about 4 to 5 times cheaper than something like Elastic Block Store. on Amazon. It's even cheaper over on Google because they have higher price block storage. It is shareable, and which means that a bunch of it's not just locked into a single computer like a block device. Many processes can see it, and it's also commonly used for data lakes. In fact, I would say even the majority of data lake information is stored in S3. One thing I should note is that when we're talking about costs, it's really important to recognize that that the costs are not just the at-rest storage costs. There's 4 other different ways that S3 can run up costs. One of them is API calls. So that's a very important, and we'll talk about that a little bit later. Okay, so this sounds great, but very quickly, it's not all. You can't just plug it in, because S3 object storage differs from block devices in very fundamental ways. First of all, it's a completely different API. It is something that applications use. It is not built into the Linux operating system, at least not the way we normally use it. Second thing, you can't update files. So unlike block storage, where you can just rewrite a block, you can't do that. So there's some of the options for doing I/O are much more limited. There's no automated caching, and there's extra costs for traffic. So for example, egress fees and API calls. So it has a completely different cost structure from block storage. So what that means is we're going to have to do some real work to fit this in. What we're going to do in the next section is talk about how that happens for merge tree storage. And just to preview this talk, we're going to talk about 2 different ways to use S3. One is to use it for merge tree storage. So we'll call that S3 merge tree. And the other model is to use it in a data lake style. We'll show you what that means at the end, but just to preview it, it means, for example, using read-only data in Parquet, which is also a very powerful model. So let's dig into setting up ClickHouse to use S3 for merge tree storage. So you're going to have to configure a number of things here. First, you'll have to set up what's called a disk, which allows you to, it defines basically a storage device that can access S3, the bucket. So buckets are where you put things, sort of locations where you can load files. Another thing, we may need to configure caching. You'll see from the performance numbers, this is very important for S3. In fact, it's critical to make it run performantly. We'll talk about volumes and storage policies, which basically make these devices visible in SQL so that you can then attach them to your merge tree table. So we'll go through all those things and show you how it works. So the basic thing that you're going to be doing when you're using merge tree and S3 is you're going to be setting up what are called storage configurations. So here's a map or a picture which shows how storage configurations work, and they use those things that I just described in before. So for example, you actually have a storage configuration in every ClickHouse server you run. It's called default, and what it does is it writes to your local disk, which is by default at Mbar Live ClickHouse. You can add additional storage configurations. For example, there's one we call here S3 Direct. And what it does is instead of using the local block storage, it's going to write to a bucket on S3. A third one that we can do is we can create an S3 cache stored policy. And what that's going to do is it's actually going to use the S3 disk, but the reads and writes are going to be, or at least the reads will be passed through a cache, which means that if we've read data out of S3 before, there's a reasonable chance it'll be stored locally, and then we can just grab it without having to incur extra costs. Let's dig into some of the details. So this is an example of how storage configuration works for the simple case where we just want to write to S3 disk. So basically what we're going to do is we'll set up inside the storage configuration tag, there's a disk section and there's a policy section. And so we'll define the disk, and basically with S3, it's a type of disk. So you see S3, it has to have an endpoint, and then it also has a metadata path. And this metadata path is very important because it's used to provide information to ClickHouse about where data, the actual files, are located in S3 storage itself. So that defines the disk. So that's something we can read and write to. And then we have a policy which uses it, and that policy sets up, looks kind of complicated. It sets up a volume. The volume contains a disk, and it really just points back to that disk we just defined. So that has set up now this policy, which we can then attach to a table, and that table will be able to read and write from S3. So before we get to actually using it, let's talk about another very popular way to organize storage, which is to layer it. And we call this tiered storage. It's a feature of ClickHouse that has existed for a number of years now. And in this case, what we're going to do is we'll set up a policy we call it S3 tiered, and we're going to have a couple of volumes, not one volume, but two. We're going to have a default volume, which is always present. We don't have to do anything. And we're going to give that a priority 1, which means that if you insert data, the first place it lands is going to be on the default device, which is local disk or SSD, as the case may be. But we're also going to have another volume, which is S3. It's and it's going to point back to that device that we just created, and it will write data there from actually to the S3 bucket. So the idea here, as we'll see, is that you can insert data, and then at some later time it will move to S3. And there's a number of reasons why that's a good thing to do. So let's just dig into this a little bit, and you'll see how this works. Here's first of all the configuration. So you can see that we've defined in this policy, we've got S3 tiered. We define the columns, and by simply listing them in this order, we're going to call one of the volumes hot, and we're going to call one of them cold. We will say, hey, the inserts by default land on block storage, and then at a later time they move to S3 disk. If you don't do anything else, in fact, the data will move when you hit 90% capacity on that disk, and that's what this move factor means. So that's one of a number of ways that we can move data. We'll dig into others shortly. So this is your configuration for tiered storage. All of these configurations can exist in the same server, and then you just use them as you wish. So final thing that we want to talk about, though, before we actually start applying them, is caches. So I mentioned that the cache is important to speed up the S3 queries. So what we can do is we can enhance our policy for S3 tiered so that we have 2 volumes, once again, block storage default. And then instead of pointing to the S3 direct, we're actually going to point to S3 cache. So that's another type. It's a special type of device, and it refers to another device, in this case, an S3 bucket. And what that means is use that, consider the cache your device, but really it's backed by S3, so go get your data from there. So this kind of rounds out the interesting ways that you can set things up. And here's an example, once again, showing here's the cache device. You can see it's cache. You can see that it refers to the S3 disk. That's the disk tag, and then it has a path for where the cache is going to be located and a size. This is an example, so it's pretty small, but it can be any size you want. You can put 500 gigs, a terabyte. Depends on you just want to make sure you have available storage for it. Okay, so that was a lot of background configuration, and as usual with ClickHouse, lots of XML, but it's pretty easy to set up, and the syntax is straightforward. Once you've done that, you can actually start to use that. So here's an example of taking that table that we introduced early on, and what we're going to do is have a new version of that table, and it's going to have a storage policy. So this is in the settings, and the storage policy points to S3 direct. So that means that we're going to actually, if we look at ClickHouse, our metadata will be stored on block storage, but we'll also have S3 available for the actual data. So if we want to use tiered storage, here's an example of how we do it. We're going to set up S3 tiered. And we're going to have the storage policy that we'll point to, and then we're going to have what's called a TTL. So a TTL, or time to live, is a very powerful feature of ClickHouse tables. And what it does is it allows us to define a rule based on the data in the table for moving things from one table to the next. In this particular case, the TTL says once the data have been in, so if you read this, it's using the D column, which is a date, 7 days after today, today's data will move to the volume S3 cache. So what that means is keep this for a week on block storage and then move it to S3. And this will happen automatically. It's basically a background of essentially a background merge process that goes and finds the data that matches this predicate at intervals and then moves it over to S3. Just to recall, there are other ways to move data. We already showed that move factor in the XML that we saw a few minutes ago. And then finally, you can just go ahead and move stuff yourself. So you go ahead and use an alter table, and the move partition clause will allow you to move a partition over to the next volume. So for example, here, moving it from the hot volume to the cold volume. You can do this at any time. So after setting up all these types of tables, it's kind of nice to just check out the performance. So what we have here is these same queries that we had before. And what we're going to do is try them out on different types of tables that are configured in different ways. So recall that each of these tables contains 100 million rows. So it's a fairly good sized amount of data. We're using, as before, an M6i 2x large. This has 8 vCPUs. I'm letting max threads just default, so it will use 4. And what you can see here is that overall, EBS, at least particularly when it's going from storage, in this particular case, is a clear winner. So the queries, even when we have to pull from storage, are complete in half a second. If we go from S3, just reading a table that is purely backed by S3, it's going to take almost 3 seconds for the longest query. Similarly, we can set this up with this same configuration up with a cache instead of writing directly. If the cache is empty, and it's pretty easy to force the cache to be empty, what we do is we see that when it's initially loading and has the same performance as the S3 direct table, the one where it's just reading and writing directly from S3. But once the cache is loaded, it has the same performance as EBS. So if your chunks of and the cache is reasonably smart, it doesn't pull entire files, it pulls sections of them. And as long as you're querying the same sections of data, you're going to have essentially the same performance as EBS. And then finally, if we look at the tiered storage, that's kind of in the middle ground, because what happens is the hot storage is on EBS, so that's going to run fast, but anything that's the more data you have in S3, the more that's going to look like S3 performance. So this gives you a sense of performance. The thing to read out of this is not so much that S3 is slow, but actually the performance is pretty reasonable, especially for data that you don't query a huge amount and where you just want to have it sitting there ready for use, but not necessarily constantly queried. So this kind of performance profile. Your EBS is going to cost you, all things being equal, about 5 times more. So the performance is kind of matches that. Let's talk a little bit about background merges, and because this is actually a really important topic for S3. I mentioned that it's not just cost of storage that you have to worry about with S3, it's also API calls. So if you have the S3 direct, if you use the S3 direct storage policy, on the left, your table is purely backed by S3, by the S3 device in these examples. When we're tiered, we're having the hot data, that's the red stuff, backed by default, and the cold data is in S3. One of the advantages of or one of the problems you run into with merges is they have to go out and touch a lot of files. So they'll have to read files, pull them down, sort them in memory, or merge them, sort them, and then write them back out again. So as a result, you're going to have a lot of activity going on in S3. One of the things that can happen if you're doing merges a lot in in S3, which could happen if you're doing a migration from another system where you bring a lot of data across, it gets plopped down into S3, it ends up having a lot of background merges, is you'll actually get errors from Amazon where operations will fail because Amazon will rate limit your API calls. So, so if you use tiered storage, you actually avoid that problem, because what will happen is that the merges will typically happen in the default device. So the data will arrive, it'll sit there for a while, it'll fully merge over, sort of hours or days. And then by the time it moves to S3, it really doesn't need to merge anymore. And in fact, there's two important volume settings that on your S3 volume that you want to pay attention to. One is what we call prefer not to merge, which says once we're in S3, don't do background merges. There's not, unless you're forced to by deleting data, there's no particular reason to just do it automatically. The other thing that we do is we set this setting perform TTL move on insert to 0. And what that says is when the data arrives in default, just make sure it stays there. Don't try and do the TTL right away, because that will take the data that's just shown up and move it into S3. What we'd really like to do is have it hang around for a while so that it can get properly merged before it's moved. So these are settings you'll definitely want to look at as your data size gets larger. Okay, so far we have been talking about S3 storage in single servers, and in many cases that's how people are running it. We talked to a lot of users, and they don't really worry about replication. What they have is a server. It's got a certain amount of hot data, and they have a long tail. They may have multiple servers with the same data, but many of you run clusters, and those clusters replicate data. So here's what it looks like if you're using local storage. You'll have a ClickHouse instance, and it'll have a disk. It might have multiple disks, but it will typically have each of those. Well, let's say you have one. You'll have the metadata, which tells you how to, your table definitions, and then all the pointers that explain your database structure, your table structure, and the piece of the parts. So those will be on the disk, and then you have the actual data itself. So the .bin files, for example, that contain your columns. Those the metadata will be shared because Zookeeper keeps a copy of it. The ClickHouse servers point to Zookeeper. That's how they learn that that there are different parts available on different servers, and then the table engine, the replicated merge tree, automatically replicates those parts by learning about them from Zookeeper, and then going and finding a ClickHouse that has a part, pulling it over, and keeping the tables in sync. So this is great. This model has been available and has worked for years. It gets more complicated when we do things with object storage. So if we are in a situation, for example, where we're just using S3 object storage and replicating, which is what this picture shows, you'll still have Zookeeper storing metadata. That's shared. But the data, in fact, will no longer be stored on disk, on your disk. Instead, you'll just have references. And if you go into the file system and sort of trace through, when you get to the files that look like they represent the parts, if you open them up, they actually turn out to be a pointer to the S3 object storage. So what this means then is, in order to interpret the object storage, we have to have this metadata and the data references fully present on the ClickHouse server. So, and then that allows the ClickHouse server to go look stuff up in object storage and fetch the data down when it needs to read it. So this is the model then that's going on under the covers. Now, this brings up a question. You can see that these arrows, these references, are pointing into object storage. The question is, for any particular part that's controlled by a particular server, what is it actually pointing to underneath? Well, that's a long story, but at the top level, there's a couple different ways this can work. You can actually, if you don't do anything special in current releases of ClickHouse, what will actually happen is each ClickHouse server will get its own S3 files. And so those data references will be pointing to separate S3 files. So in effect, ClickHouse replication will be replicating parts also in S3. So, and you'll if you go through this, you'll see both of them. This is not very efficient for large data sets. So say you're storing a petabyte of data. What you'd really like to do in S3 is take advantage of the fact that, hey, it's visible and everybody can see it. So why not just have one copy? This is what we call a zero copy structure. That's over on the right, where those data references, in fact, point to the same files and they're basically shared across each. They're basically shared by all servers in the cluster. How do you enable this? Well, there is a merge tree property called allow remote file system zero copy replication. It's kind of a mouthful, but when this is set, and what you typically do is you're going to set it at the merge tree, you're going to set it at the database level, and any table which uses S3 will then automatically get this property so that the files will be shared. And that basically turns it on. And at that point, the amount of S3 storage that you're using will drop, to a single copy. So for example, instead of having, you'll store a petabyte of data if that's what you have, instead of 2. So, so that's a really powerful feature and something that people are using increasingly. In fact, this is a good point to when I say increasingly, the S3 storage is in a state of evolution in ClickHouse right now. And so I just want to give you kind of a summary of where it's at. And that is, first of all, there's good things. So it is usable for long tail data. And in fact, we have a lot of customers that are using it quite successfully. Many of them are using the, just single, each server has its own copy of data. That's the current model many people are using. And that works reasonably well. It's, as we showed, the performance is not bad. It's getting better. The replication works. We do recommend with object storage that you be as close to the most recent version of ClickHouse as possible. So, for example, as of today, that's 23.7 because there are constant fixes coming in for this. And then there's a setting max parallel replicas that enables scale out, so you can actually use the replicas to distribute the queries. You don't have to have shards necessarily to get the effect of distributed queries. You can actually spread the queries out across all your available replicas, and you get good parallelization on this data that they can all see. So there are some things that are still challenging. If we look at the model, the S3 only contains data. It doesn't contain these references. In other words, this metadata that's necessary to know what you're looking at, that's still on the ClickHouse server. And in fact, every ClickHouse server needs a full copy of that metadata. So this model doesn't really scale out to all nodes. The other thing that is really important to know is that zero copy replication until recently was somewhat unstable. So for example, just this whole thing of making sure that the reference counters stay in sync is difficult. If anybody gets out of sync, then you may have people pointing to different data. So, and there's a question coming up about how we compare this with shared merge tree. We'll talk about that a little bit later. Another issue with S3 in general is it's just hard to do backups. So there isn't a, we are actually working on enhancing ClickHouse backup to handle this, but S3 has to be treated quite differently. So you need to sort of remember configurations. You need to avoid having files deleted. It's for the same reasons that ClickHouse did a huge amount of work to just handle S3 table data. Backup also has to do the same thing, because backup right now, for example, in ClickHouse backup, it depends on the semantics of block storage drives, things like hard links, for example, and these are more complicated to do effectively in S3, and the volumes of data are larger. So you need to use different approaches. The other thing about zero copy, specifically zero copy replication, is that there have been a number of great recent fixes. I think over the last couple of months, or last few months, we've seen something like 24 PRs land. Many of them are really important fixes. They still need full verification, so there's still a few bumps here, but it's getting better really fast. And this is something that happens with ClickHouse that, once it gets attention, it gets fixed fairly quickly. So that's the current state. I think here, actually, it might be good to comment very quickly about the shared merge tree. We can just take this here. What does shared merge tree do? So shared merge tree basically solves this problem by making it by managing the references in a much more coherent way. It does a couple of key things. First of all, it basically allows the S3 object storage files to become easily attachable to any number of servers. And it also has solves the problem of data references by allowing or in a fundamental way, by allowing the servers to contain partial sets of partial information about the entire set of S3 files, so that you don't actually have to have this data reflected onto every single onto every single host. Alexander, do you want to comment more about shared merge tree? Details on that if you're
I think that that everybody, or probably most of the people, they read the article from ClickHouse about shared merge tree that actually explains the difference in approach between the current merge tree implementation and shared merge tree. But if you look into this picture only, then the fundamental thing that they did is moving data references out of ClickHouse to Zookeeper or Keeper in the example. And when the data for references is stored in a single place, then many good things are happening for free almost, right? You can attach multiple servers, you can do this dynamic sharding. There are no problem. Actually, there are different sets of problems, of course, but zero-copy replication becomes kind of unneeded, and etc., etc. They did also more things. They actually collapsed metadata, which into smaller number of files and objects that decreases amount of calls to S3. Remember, we were talking about extra cost that may occur due to extra API calls to S3 API. So they thought about that as well, and made the structure in ClickHouse to be more compact and more suitable for S3, even if it's probably not very convenient to do on block storage. So things like that, and we can get in depth discussing that, but unfortunately we're short on time.
We're going to short on time, and the other big thing to know is it's closed source, and ClickHouse Incorporated has no plans to open source it at this time. They may change. So that's actually an important topic, and we'll return to that at the end of this talk. So thanks for that question. All right, let's talk about, we've still got a few minutes here. Let's talk about a final way to use S3 inside ClickHouse, which is a data lake approach. And for this, we're going to, merge tree is great, but it's not the only format for data in the world. In fact, there are others, and in particular, Parquet is a really popular format that is columnar, has indexing, has very good compression, and in many ways is a worthy counterpart to merge tree. It's the difference being that it's a public format, and anybody that, for example, can access arrow libraries, say from Python or from C++, can read it. So ClickHouse has put a lot of effort into reading files directly off S3. This is a feature that started to develop, I think, about 2020 was when it really became usable. And then there's been, particularly in the last few months, been a lot of effort on reading and writing Parquet very quickly. So this is becoming a very powerful approach. Let's just look very briefly at how you can use it. So ClickHouse offers what's called the S3 table type, which will basically read files out of, or excuse me, table engine. It will read files from Parquet, or excuse me, from directly from S3. So the way you set it up is we could define our table. We pick S3 as the engine. We provide a URL that we can get to, and we we say that the table type is going to be Parquet. It doesn't need to be told what's in there because it already has a schema and it can figure it out itself anyway. We can then insert data into this. And this would basically, in the current implementation of the S3 table engine, it would take these rows and would basically create one fat Parquet file. You can, there is limited support for partitioning, but basically this is a very simple-minded use of sort of read and write of Parquet through this engine. Now, when we're actually selecting, we start to see more ways to select. So we can select directly from the table. And as long as it fits, the table doesn't deal with partitioning very well. So if it's, as long as it's, in a, like for example, in a single file, it will be perfectly happy to run these, run this. And these are examples that we see right here. But what we can do actually is the second example, we're not actually selecting from the table, we're selecting from the S3 table function. This is a really powerful table function. And we give it a URL, we say that it's Parquet, and what it's going to do is it's going to be just like building a table on the fly, and we'll be able to pull the stuff off. The difference is that this table function is very good about reading multiple files. It has very powerful file globbing capabilities. And then finally, there's a variation on it called S3 cluster, which will run S3 function, table function runs on the current server. S3 cluster will distribute the work across all servers. And what that means is if you want to run a query, ClickHouse will dynamically spread it across multiple servers to get you your result back much more quickly. So these are all available to you. And let's do a quick, again, a quick performance test. The performance is actually not bad. What's interesting is in these tests, and your mileage may vary, in these tests, the Parquet queries that we're testing here with 100 million rows, they run faster than Mergetree does on S3. So you can see here the maximum query speed was about 2.0. EBS was the same, but the maximum query speed was 2 seconds or less from Table Engine and Parquet. So really pretty decent performance. And this is why this approach of sticking read-only data into Parquet is actually quite practical and a good way to store data. So I mentioned that the S3 table function is more powerful. Here's an example. What it can do is it can insert, particularly for writing data, it handles partition data very well. So for example, what it will do is this particular example will break the data up into separate files, and so that you don't have just one humongous file, but you'll break them up by the partition ID. And you can see there's a partition clause here that tells how we're going to split it up. Our data will be, it's partitioned by days as it already happens. In the previous example, so it's just going to split up the files and send them, split up the data and build separate files for it. So S3 tables function is better for insert. It's also really good, as I mentioned, for then doing the queries. Once you've inserted this data into multiple files, you can now put globs in, and they are much more powerful than this. You can have, you can basically select, from multiple similar paths, with a couple different, sort of different variations of parts of the path. So it works very well. One thing that's really important about this, there's a question here. Can this solution, I think is a great time to address this, can this work with any kind of S3-like buckets? Answer is yes. It works best with Amazon S3. And one of those, the simple reason is it's just been used a lot more on that, but it also works on MinIO. It will also work on GCS. It will, Oracle buckets, I don't know of any person who's used it, but as long as it's S3 compatible, it should more or less work. You will see, if you're using a new bucket type that hasn't been used as much, the chances are you may sooner or later see a bug, but they do get fixed, and it works very well. So
Robert, let me comment on that. Yeah. So if there is a S3 compatible API and the bucket may present it is a S3 bucket, then the question is how well this API implements S3 functionality, because there are some things like multi-part uploads, the different authentication, authorization schemes, etc., that may vary between providers. So this is kind of on provider side. ClickHouse also can work with GCS and Azure block storage directly, because developers integrated those APIs directly into ClickHouse. For Azure, there was a native API used. For GCS, I think there was a wrapper on top of S3 API provided by Google, so it's a little bit limited, but it understands specific authorization schemes for GCS and some others. So just Robert's answer to the question is yes, but there could be some details and some things may not work as well as they work in S3.
Let me give a concrete example. So MinIO, if you're doing a multi-part upload to MinIO, there is a pause in the API so all your parts go up, and with S3, once the last byte arrives off the net, S3 just kind of says, got it. It may have to do some organization, but that's not your problem. You can go away and it's got your data. On MinIO, there's actually a pause as it syncs the data. I don't know what the underlying implementation is, but in some cases, and this actually came up in a support case, it caused the connections, the write to fail. It actually timed out. And so these are difference in that the API functionally is the same, but the actual behavior is a little bit different in practice. And then you can hit, as we did in this case, a timeout or some other problem. So it's not to say it doesn't work. In fact, MinIO, I don't want to diss MinIO. We use it constantly for across ClickHouse. It's the go-to for doing unit tests. So it's used every day, and it's in the build pipelines and so on and so forth. It's just, we want to be clear that there are some differences here. One thing that we didn't talk about yet, but I think it's a good time to dive into it, is how to pass S3 credentials in. There are many methods of doing this. Probably the one that I personally prefer and the simplest is to pass it in as environmental variables. The reason I like this is it turns out in Kubernetes, this is super easy to implement. You can just create a secret, and then you can pass these, have the secret, pulled into the process as environmental variables, and that gives you access. You can actually pass the keys as strings in every one of the, the S3 endpoint definitions like this allow this. You can do it in the S3 table function, but what that means is you have keys lying around, which is not a good thing. Sooner or later, you'll check them into GitHub, and then you'll get a message, and it'll just be terrible. So that's probably not the best. Another nice way to do it in each of these, in each of the clouds, there is generally a method of defining roles and actually grant those roles directly or indirectly to ClickHouse, so that the ClickHouse process in effect has built-in permission to access whatever S3 bucket you're looking at. That's great because there are no keys at all, and there's no necessity to move stuff around, on the operating system, because it has it has implicit access. And then finally, you can use name collections. They're really just a different way of defining the data that's stored in an endpoint, but they also work. And it means that, for example, with S3 table functions, you don't have to. You can just use a reference, which then refers to something that doesn't appear in the SQL and isn't in your logs. So these are all great ways to pass credentials. You can take your pick. There's pretty much something for everybody. Trade-offs with Parquet, I'm not going to belabor this because I want to make sure we have time for connections or questions, excuse me. But this is, the one thing I would say is this is something you want to think about if you have a use case where the archive data is truly, the old data is truly read-only. That's not the case with a lot of people. Like if somebody's going to come in and say, hey, I want my tenant data deleted, it's not a good pick. But for observability data, for example, that just never changes and you want to keep it, Parquet on S3 is a really good option. The other thing that's nice about it is once you put it out there, it's not just ClickHouse that can read it. If you have machine learning, if you have, your data, your data science people, they can also access those files without going through ClickHouse and putting load on operations that are running your operational analytics. So it's a really powerful feature. Okay, let's talk very briefly about S3 telemetry. I'm just going to say we have the telemetry has gotten way better in ClickHouse for this. The following 3 slides, which I'm not going to cover, show examples of the telemetry. You can read them when you get the link, but it's now increasingly easy to get to get information out to see what ClickHouse is doing with S3. For example, if you're getting a lot of API calls, being able to detect those easily is now possible. You can fetch data about the file system cache, and then it's pretty easy to check the allocated storage size. One trick that I want to highlight is the system remote data paths table. You may not know about this. This keeps track of the actual files that ClickHouse is managing in S3. You can see their paths. You can use this to check the data size easily and to find out individual paths. And speaking of file paths, we don't mention it on the slides here, but there is a new utility called ClickHouse Disks, which actually allows you to can read the paths when you're on the ClickHouse instance. It's not documented right now, but this is something that over time looks like an increasingly useful tool to figure out what's going on with those references on disk. Coming attractions. So we talked about shared mergery, which is, as we mentioned, from ClickHouse Incorporated. Looks like a good design, but it is unfortunately closed source and quite likely to remain that way for a while. The other thing that is interesting is that not everybody runs in ClickHouse Cloud. Of course, we don't. But so there's an sort of a lot of interest in what everybody can do in the community to improve the existing open source S3 capabilities. So, for example, doing more work on zero copy replication to make sure that it is 100% stable and stays that way. Simplifying storage organization, as we've kind of alluded to, it's somewhat complicated, all the way down to things like documentation. So if these are things that are of interest to you, I would invite you to join community efforts or talk to us. We're very actively involved in this and looking for ways that we can also help to make S3 storage better. This is a really critical feature for ClickHouse. The good news is that it's evolving quickly and becoming increasingly useful. We see lots of production deployments on it, but it can always use more help from the community. There's it kind of like Parquet performance, which is increasing rapidly. The more hands we have working on this, and the more you help us, the more we can help improve this. So with that, we're getting toward the end. What I would like to do is we have some best practices, which are a little bit empty. I'll just gloss over these and instead open it up for questions. So you can read these in the slides. References. Don't forget there's samples of all the things we've talked about here. Here's the link, ClickHouse SQL examples. There's the documentation. There is a great blog by Double Cloud that explains how the S3 storage works under the cover. It's the best treatment of the topic to date. And then for practical user things, Denise Jaralev and other people on the Altinity support team have written great KB articles. There's a really excellent one, which is linked here, that actually I used for the samples for this talk. And then we do regular blog articles on this as well. So with that, I'd like to say thank you. If you'd like to talk to us more about this after the question and answer, please come visit us at altinity.com. You can schedule a consultation. You can join our Slack. The invite link will be you can see it it's available from one of the menus inside our website. And once again, we do altinity.cloud. So we could run this stuff for you. You don't have to deal with this stuff. We'll take care of it. We do stable builds and the Altinity Kubernetes operator for ClickHouse, as well as ClickHouse backup. These are all things that we work on, and we'd be delighted to share with you. So with those, I want to thank Alexander. Yes, so the public Slack channel for the ClickHouse community, when Alexander takes over answering the questions, I am going to go ahead and post that public Slack channel we'd love to have you join us, and we'd be happy to answer any of your questions there. Okay, Alexander, I'm going to go ahead and make you the host and let you take over questions. So let me just confirm that this is.
Yeah, thank you, Robert.
Yeah, and thank you so much for helping on this talk. Lots of great information.
Yeah, I can stay here for 5-10 minutes or more if there are more questions. And I will try to answer questions both verbally than in writing some version in the chat as well. A few of them are already answered. Maybe we can discuss them a little bit. But the last question is about zero-copy replication production readiness. In fact, zero-copy replication has been developed in Yandex for their cloud several years back, and it is in production for 2 years for them. During this time, they definitely hit a lot of problems. They were losing customer data. Don't tell anybody, and they were fixing bugs. ClickHouse folks, they started to use it in their ClickHouse cloud as well before they developed shared Wizardry, and they were also spending their time fixing bugs and problems. So that great effort has not been forgotten, and now they claim that zero-copy replication is production ready. If you use the latest ClickHouse versions like 23.6, 23.7. Backup is a different story. In fact, ClickHouse still don't have a good backup solution internally, and there is embedded backup command, but it is just a command. It is not a solution, so it cannot be used for maintaining list of backups, for example, for setting up backup frequency, TTLs, and stuff, for restoring with some specific scenarios that people hit in production. ClickHouse backup utility that Altinity is maintaining, it is much better in terms of management. So it allows you to manage your backup infrastructure in a universal way, but it's still not. It still doesn't work very good with S3 storage. We're still working on that. Every new version improves in this regard, but some problems may still happen.
Alexander, you've got another question, and which is, does creating bigger parts or files reduce API costs? You see that one?
Yeah, yes and no. So it depends on what you do later with your data. When ClickHouse queries the data, it needs to read. Sometimes it does make sense to read the full part, right? So if you have partition in a single part and you query just a fraction of this data from this partition, and then ClickHouse will anyway have to do some multiple requests to S3 in order to read this data. But you're right that having a smaller number of parts is better in general. It is better for S3 because the less amount of objects you store in S3 is better in general. Maybe if you're working with S3 and you're trying to calculate the size of your bucket using an S3 client, you could see how long does it take to do even this very simple operation. So S3 has to iterate through all your objects in the bucket to calculate the size. This is very long time. So the less number of objects you have in the bucket, the better it is for performance and for manageability. Okay, what's the next question? There's a question in the chat as well that I missed. Yes, you're right, Aaron, you're right. So with the current Wizardry implementation over S3, there is still a fraction of the data which is still not separated when the storage is still not separated from compute. This is what we called references. These are references to objects themselves. And the reason those references has been developed because object storage is very limited in operations that are typical to file systems. So you cannot easily move the object, right, from one place to another. You need to do a copy and then delete an old version. This is very slow. If you know how ClickHouse works internally, when it does a lot of operations on the parts, it very likes to do hard links. If you do some mutation, right, and then all the data that doesn't change, it is copied through hard links. It is very efficient in a file system, but it doesn't work in object storage. And in order to overcome this limitation, developers created those links so you can manipulate on links level and don't touch the object themselves. So objects are immutable in object storage. But that created this different problem when there is still no clear separation, when this metadata of references, the data of references, it needs to be protected. If you lose it, you cannot restore the data which is stored in object storage. And all the bunch of our problems. And this is what ClickHouse folks tried to solve in shared merge tree. Do we find the S3-backed merge trees are more CPU intensive on reads compared to those backed by SSD HDD? No, I don't think so. It should be pretty much the same in terms of CPU usage, but if you try to split CPU usage on different things, how much it was waiting, if you only consider user time, it is the same. But if you consider wait times, that should be different because CPU may wait for data to be read from the storage. This is one number, or CPU can wait for data to be read from the network, which is yet another number. What might happen if you're using ClickHouse with S3 is that ClickHouse might create a much bigger number of threads that try to read the data from S3 or write the data to S3. This is done definitely for performance reason, because usually creating more threads may create a bigger bandwidth. So even if you have one thread which is executing the query, ClickHouse may create a lot of threads reading from the storage and even bigger threads when reading from S3. And that in turn may generate somewhat higher load on CPU as well, because you have more context switches and stuff. So question from team, if metadata also stored in S3, again, can I create a ClickHouse instance, tell it to store in S3 and then start a different method pointed it? Almost. By almost, I mean that there is a special disk type that we haven't discussed in this talk. It is called S3 plane. And you can put the data on S3 plane and then attach it to ClickHouse. The problem with S3 plane is that it write once kind of write once solution now. You can create the data on S3 plane only using backup command in ClickHouse, if I understand correctly. And then you can attach it to another ClickHouse server, probably for restoration purposes or for inspection purposes. One thing that we are considering to improve in ClickHouse, I mean Altinity, is to make this S3 plane to be more generally available for tiered storage, for example. So what we can imagine is that once the data is called and historical enough, you probably don't need to change it at all, right? So your whole data is is probably changing. You're running some mutations, but cold data, it's already merged to big partitions, to big parts, and you don't expect it to be changed. Then it can be moved to this S3 plane in the structure, which is identical to the structure of the data in ClickHouse itself. And when it's stored in S3 plane, it can be attached to other servers and can be shared or moved very easily. Right now, it is kind of possible, but not very convenient. Okay, one more question from Aaron regarding better suggestion for backups. I touched it a little bit, but there are 3 solutions right now. Actually, even 4 options. If we're talking about backup in cloud environments in general, one is ClickHouse embedded backup command. It can produce a snapshot of the data and store it on S3. The problem is that it still has some bugs with restore functionality in particular. It doesn't track dependencies properly, and it is not a management solution, right? As I said, you cannot manage list of backups, you cannot manage schedules, etc. Another solution is ClickHouse Backup from Altinity. This is open source utility that supports different backends, not just S3. I think all major cloud providers, including Chinese cloud providers, are supported. Then I think that a Double Cloud has outsourced their backup solution recently. This is what they use internally in their cloud. We can find the link and probably share it with community. It has been put in open source probably last month. We have 0 experience with that, but we know that it has been used quite extensively in production for many years, maybe for 5 or more years in Yandex Cloud and Double Cloud. And also you can actually experiment building their own. We have some customers who are making EBS snapshots when they are running in the cloud, not with S3 storage, but with traditional EBS storage. It is possible to do EBS snapshots. It even supports incremental backups because AWS internally, if you do snapshots for the volume, and if you do a next snapshot for the same volume, AWS can do an incremental snapshot in some cases. The problem is how to recover consistently, but you may use the following approach. Stop all ingestions, stop all merges, so your ClickHouse is idle completely. Then, only then, you do a snapshot, and then you resume all operations. In this case, you have more or less consistent snapshot of your data, and you can use it in order to recover. But again, this requires quite a lot of automation that I don't know if it exists in open source or anywhere else. Question from Rodrigo: have you hit any S3 API limits during the tests? We didn't hit any limits, but you can yeah, right. But the number of API calls per second is pretty high. What am I talking about extra costs is that actually every API call to S3, it has some cost, which is pretty low. But when you're running very extensive workloads, which are S3 only, then those costs start to accumulate and may be quite significant. We know for sure that ClickHouse has been optimizing their cloud for this sake, because they were also starting to be concerned from very high costs on S3 API. But limit-wise, even if you hit them, you typically can reach AWS support and the baseline. And on a small instance, there is very little chance you can hit the limits. Question from Zhang Huan: is utilizing a S3 warm disk the best choice for read-only table? I don't sure understand what you mean. What is a warm disk? maybe you can ask it differently. For read-only, actually, cold is better. Write once, read many. Okay. Yes, you can do it for it on the table. Sure. So this is what S3 plain can work for right now. Any other questions? Going once, going twice. Okay, then thank you everybody. Robert has to leave earlier for another for an important customer meeting. But thanks Robert, and thank you guys for attending. I think it was interesting. We will share the recording and slides with you, and I think we will continue talking on this topic because this is one of the very important functions in ClickHouse, and we actually haven't covered everything that we could. There is a lot has been left for the future talks. Thank you, and have a good rest of your day. Bye.